In our last unit, we looked at solving right triangles. In this unit, we're going to look at solving non-right triangles. So in that scenario, we cannot use our primary trigonomic ratios, sine, cosine, and tangent. However, there are two laws we're going to look at. The first one is called the sine law. Any acute triangle, ABC, if we take side A and divide it by the sine of angle A, it's equal to side B divided by the sine of angle B, which is equal to side C divided by the sine of angle C. Or we can have the reciprocal of that same equation, as long as your triangle is labeled as the one given here. Across side C is angle C, across side A is angle A, and across side B is angle B. And if that's true, then we can use the sine law. Normally we would spend time developing the formula, but due to our time constraints, I'm just going to go through how to use this formula. So example 1. Solve triangle ABC given that A, side A, is equal to 12.0 meters, angle B is 55 degrees, and angle C is 45 degrees. So given that information, the first thing we should do is draw a picture. Next, let's label our vertices as A, B, C, as indicated by our example. And then similarly, let's find our sides. We know this would be side B, because it's across angle B. This would be side A, because it's across angle A. And this would be side C, since it's across angle C. Including the information that was given, we know that side A is 12.0 meters. We also know that angle B is 55 degrees, and we know that angle C is 45 degrees. In the question, it asks us to solve, so that means determine all side lengths and all angles. And the first thing we should do is focus on angle A. So angle A, recall using our 180 rule, is 180 degrees minus the sum of the two other angles, 55 plus 45. So that gives us 180 minus 100, which tells us that angle A is equal to 80 degrees. So we can add that now to our diagram. Next is to find side lengths. And again, we cannot use our primary trig ratios because this is a non-right triangle. So we're going to start by finding side B. And in this case, it doesn't matter which one we start with. And since we're looking for side B, I'm going to use this version of the sine law, the one with the side on top. So I want to find side B, so I know if I look at the formula, then I'm going to need the ratio B over the sine of angle B. But then I need what's called the known ratio. I need either A over sine A or C over sine C, but I need to have that information. So if you look, I have side A and I have angle A. So that is the ratio I'm going to use to compare B over sine B. A over sine A. So what I like to call this is my known ratio. I know side A and I know angle A. And on this side, I like to call this my unknown ratio. Again, I don't know side B, but I do know sine of angle B. Next is to sub in our values. So I have B over the sine of angle B, and we see that angle B is equal to 55 degrees. And then I write in my A, which is 12.0, over the sine of whatever angle A is, which in this case is 80 degrees. Next is to isolate for B. I have B divided by sine 55, so the opposite operation is to multiply both sides by the sine of 55. And if I do that, I can cancel the sine 55s on the left side. And I have that b is equal to 12 sine 55 all over sine of 80 degrees. And the last part is just calculator work. First thing, remember that your calculator needs to be in degree mode. And then let's type in what we have. 12 times sine 55 and then divided by sine of 80. And if I do that, I end up with a side length of 9.98, or approximately 10 meters. So there's side B. Let's try this one more time. So we can add this to our chart if we like. So side B is equal to 9.98. Last side we need to find is side C. So let's do that here. We want to find side C. So again, I need my unknown ratio. So that means I'm going to start with side C because that's our unknown, which means I need to divide it by the sine of angle C. And then I have to have my known ratio, which is still A over sine A. You could now do B over sine B, but you need to be careful because if you made a mistake in calculating B, that mistake will carry into calculating side C. So let's put in our values. So side C is our unknown. Sine C, this time we have sine of 45 degrees, equals, same thing as the other side, 12 over sine of 80. That's side A over the sine of angle A. I want to multiply both sides by sine 45 because I want to get C by itself, which tells us that C is equal to 12 sine of 45 degrees divided by the sine of 80 degrees. And finally, we can approximate the side length for C. So we type this in, so it's 12 sine 45 divided by sine of 80, which gives us 8.62, or approximately 8.62 meters. So there is side C. There is side B using the sine law, and up top was angle A. So we can take C 8.62 if we like and add it to our diagram. And there we have all the side lengths and all the angles. So this is one use for the sine law to help us find the side length. Let's look at our second example where we can also use it to find an angle. So new triangle, triangle DEF. Let's sketch it. So D, E, and F. We know that angle D is 47. We know that side D, that's opposite angle D, is 78 centimeters. And side E is equal to 106 centimeters. So the question is, where do we start with this? And that's usually the toughest part. So we need an unknown ratio and a known ratio. First of all, we see the known ratio is going to be D over sine of D. And the only other side length we have is E, so we should probably focus on finding angle E to start. So once again, I know D and the angle D, and I know side E, but I don't know angle E. So we're going to start by finding angle E. That's going to be our first angle we're going to look for. So we're going to start with angle E. And remember, there's the second version of the sine law where we put the angle in the numerator. So this is my unknown ratio. Sine of angle E over side of E is equal to the sine of angle D, the one we know, over sine over side D. So next part is to sub in our values. So sine of angle E over side E, which is 106, equals the sine of angle D, and angle D was 47, divided by side D, which is 78. And the same as before, we need to get the E by itself. So our first thing, it says sine E divided by 106. So the opposite operation is to multiply by 106. So this gives us that sine of e, remember because these cancel, is equal to 106. I would leave it in front of this sine, times sine 47 degrees all over 78. The problem is we don't have e by itself. And recall that if we are looking for an angle, we need to use the sine inverse. So the last step is to say that angle e is equal to the sine minus 1 of 106 sine 47 all over 78. And with most of your calculators, as long as you put brackets in the right spot, you can do this calculation all at once. So on my calculator, I'm going to hit the second button and hit my sine button to get my sine minus 1. And then I put an open bracket, unless your calculator puts that for you. Then I'm going to type in 106 times sine of 47 degrees. Close the bracket if my sine requires a bracket. Then divided by 78. And then close the bracket for the outer one. So on my calculator, it looks something like this. I have to get the sine minus 1, an open bracket. I type in 106 times sine, and then I put the 47 in brackets, then divided by 78, and close the bracket again. And if I do that, I end up with an angle of 84 degrees, or approximately 84 degrees for angle E. So I go back to the top here. I can now put in 84 degrees for angle E. All right, that wasn't too bad. Now we can find angle F. Angle F, using our 180 rule, is 180 minus the sum of the other two angles, so 84 plus 47. And if we calculate angle F, we get 49 degrees. So that's two parts done. And the last part now is to determine side F. That's the only thing that we're missing. So to find side F, this is the same thing that we did above. We need to start with one unknown. And remember, we're using our sine law. So we're going to get F over the sine of angle F. Notice I started with the side on top because that's what I'm looking for. And again, the known ratio that we have is D over sine of angle D. Next, we sub in our values. So we have F over the sine of whatever angle F is. We have angle F equal to 49 degrees, which is equal to D, which is 78, over the sine of angle D, which is 47. Similar to what we did above, this is F divided by sine of 49, so the opposite is to multiply by the sine of 49 on both sides. The 49s will cancel. And we have F is equal to 78 sine of 49 degrees all over the sine of 47. Last part is to use our calculator to estimate the value of F. So 78 sine 49 divided by sine 47 gives us an approximate value of 80.49 or 80.5 centimeters. So that is the last value. So let's add that there. 80.5 centimeters. And our triangle is now complete. All right, so we're talking about the sine law, so let's summarize. So we can use the sine law to solve a problem modeled by an acute triangle. That means all angles are less than 90 if two sides and the angle that is opposite one of these sides are known. So let's draw case A. So first of all, we can use the sine law if we know two sides and we know one of the angles opposite one of the sides. So let's say this scenario here. Or if we have two angles in any side. So if we have two angles in any side, we can have these two angles and let's say this side. And again, it doesn't matter what side, because once we have two angles, we know the third. So these are the two scenarios where you can use the sine law. When does the sine law not work? So there's two cases where the sine law will not work. So first case is I have this side, and this side. The sine law will not work because you need an angle across a known side, and in this scenario we don't have an angle anywhere in this triangle. The second scenario is if I know this side, and this angle. Again, I don't know the angle here across that side. I don't know the angle across this side, and I don't know the side across this angle, so I don't have a known ratio. So the sine law will not work unless you have an angle across a known side.